Hey guys, it is 4.6, our last lesson before you take the study guide and take your quiz. This is solving quadratic equations with complex numbers. Our objective today is students will be able to solve quadratic equations with complex solutions. So as we saw before, we start using the quadratic formula, which is right here. Minus b plus or minus the b squared minus 4ac, everything over 2a. This works for any quadratic equation. When a is 1, when a is bigger than 1, any quadratic equation. So we also saw that the discriminant, which is the piece that's under the radical sign, which is b squared minus 4ac, if it's negative, we know we can get an answer. If we put square root of negative 12 in the calculator, we get an error, undefined, or something like that. So what we're going to do, those are where we're going to get complex solutions. So we're going to work on one example together. As always, what's my a, what's my b, and what's my c? So in this example here, x squared minus 4x plus 29, my a is 1, my b is negative 4, my c is 29. So I want to go ahead and set up my quadratic equation. Using my quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4 times 1 times 29. So let's bring my radical sign all the way out. Everything over 2 times 1. This works out to be 4 plus or minus the square root of negative 100. Plug all of this into your calculator the same way it is. No radical sign is needed, just what I highlight. All of this over, oh, I don't need the highlighter, I need a pen now. All of this over 2. Now we know that square root of negative 100 is actually undefined in the calculator, but remember we said the square root of negative 1 is equal to I. So what I want to do is split this up where I get 4 plus or minus the square root of 100 times the square root of negative 1, everything over 2. This becomes 4 plus or minus square root of 100 is 10, square root of negative 1 is I over 2. And then the last thing, it says express your answer in the simplest. The 4 can be divided by 2 and 10 can be divided by 2. So in simplest form, this becomes 2 plus or minus 5i. And this is the solution. These are the two roots to my quadratic equation. Before you get confused, let's do 2 more. Now, when I want to do this, my goal is to get my equation in the form ax squared plus bx plus c equals to 0. So I am going to go over this one step by step. Minus 7x on both sides. That's cancel. You're left with x squared. Minus 5 minus 7 is minus 12x plus 30 equals to 10. Now I want to minus equals to negative 10. Yep, sorry. Then I want to add 10, do the inverse on both sides. This is canceled. I'm left with x squared minus 12x plus 40 equals to 0. Now this looks like something that I need, that I can work with. So again, the first thing as always that I would like to do is what's my A, what's my B, and what's my C. My A is 1, my B is negative 12, and my C is 40. So I want to use my quadratic formula now, which is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2, not a, my a is actually 1 now, over 2 times 1. Now this works out to be x is equal to 12 plus or minus the square root of negative 16. Again, you want to put these numbers without the square root in the calculator, and you should get negative 16 over 2. But how do we break this down? Remember, this is broken down as 12 is the plus or minus square root of 16 times the square root of negative 1 over 2. This is 12 plus or minus 4i. Square root of 16 is 4. Square root of negative 1 is I over 2. And then simplest form, I can break this down even more as 6 plus or minus 2i. And this is my final answer. Okay, it's not that difficult. The quadratic formula, that's it. Now let's go on to B. So again, I want to make this into the form here. So what I need to do, this becomes this here. We see we have x squared plus 6x plus 11 equals to 0. Minus 10 on both sides and then minus 4. You guys can do that silly step by your own. You can do it in your head. You're juniors, you're in algebra 2, you got this. I don't need to work these steps. I did it over here. Now you're going to do it on your own. A is equal to 1, B is equal to 6, C is equal to 11. My first step. And let's get rid of this so I have some space to write. You should have copied this already. If not, go back in the video and make sure you get these done. Okay, quadratic formula. My quadratic formula is minus b plus or minus the square root of 6 squared minus 4 times 1 times 11 over 2 times 1. Again, everything in parentheses under the radical sign. What do you get? You should have gotten the square root of negative 8 over 2. Now, this piece right here did not give us a perfect square. So what we're going to do is break this down. This becomes negative 6 plus or minus the square root of 8 times the square root of negative 1. We know the square root all over 2. We know the square root of 8 can be broken down as what? This is negative 6 plus or minus the square root of 4 times square root of 2, and then bring this down. Factors of 8 are 1 and 8, 2 and 4, and that's it. And this is the one that I'm going to use because 4 is a perfect square. All of this goes over 2. And then I want to just simplify now. So this becomes minus 6 plus or minus, what is this work out to be? Square root of 4 is 2. The square root of negative 1 is I, and then the square root of 2 stays the same. All of this is divided over 2, and because they want it in simplest form, I know negative 6 divided by 2 is negative 3 plus or minus negative 2i divided by 2 is I, and then the square root of 2 remains the same, and this is my final answer. No, like it seems a lot, but it's the same thing that we have been doing, solving using the quadratic formula, which always works, but now we have that negative under the radical sign, and those are my complex solutions. So moving along, so it says consider the parabola whose equation is given as y equals x squared minus 6x plus 13. So again, the first thing, what's my A, what's my B, and my C? I want to solve this algebraically. So I am going to do what I just did with the quadratic formula. This becomes x is equal to minus b plus or minus the square root of minus 6 squared minus 4, 1, and 13, that's my C, over 2 times 1. Now if we were going to simplify this, I will get 6 plus or minus the square root of negative 16 over 2. Now, I'm going to write here and then take this off, so make sure you get this copied down. This is actually the same thing as 6 plus or minus the square root of 16 times the square root of negative 1 over 2. This is simplified as 6 plus or minus, what's the square root of 16 is 4. The square root of negative 1 is I over 2. And then they want your answer in simplest form, which is 3 plus or minus 2I. Remember, this from here is the same thing as 6 over 2 plus or minus 4 over 2 with the I. I just simplify these, just to clarify that. Now it says, using your calculator, sketch the graph of the parabola. So go to your graph, enter this, and you're going to use these windows. You should have a parabola that's something like this. Should be a little better, but it's something similar to this. Part C says, and I'm going to take this off, make sure you have these copied. Part C says, from your answer to A and B, what can you say about the parabola whose zeros are complex roots? So anytime you have a quadratic formula and the zero is a complex root, meaning there's a negative under the radical sign, it means that that's a complex solution. So it always states and it always implies that the parabola will not cross the x-axis. So again, this here was equal to 6 plus or minus square root of negative 16 over 2. Whenever you have this negative under the square root, it just means that it will not cross the x-axis. And as you can see from drawing it, it would never intersect this axis. This axis, sorry. Now the second to last thing that we're going to talk about is how can we use a discriminant, remember the discriminant, the part that's under the radical sign, to determine whether it has an x-intercept. So your discriminant is, remember this, discriminant is equal to b squared minus 4ac. To determine whether it has an x-intercept is where the graph crosses, or some of you like to call it intersect, I-N-T-E-R, intersect. Let's spell that correctly. Intersect the x-axis. So that's what the x-intercept means. Now, let's see how this works. So my A is 1, my B is -3, and my C is -10. That makes my discriminant 3 squared minus 4 times 1 times -10. This is 9 plus 40, which is 49. So what this, it says that use the discriminant to determine whether it will cross the x-axis. So yes, it will cross because the discriminant is positive. So whenever the discriminant is positive, it means I will have a graph, and this is not necessarily the graph, but I will have a graph that intersect the x-axis. So let's say this is my graph. I will have a graph that will intersect the x-axis like this versus what I had up here where there was no intersection. So if it's positive, it means it will have it will intersect the intercepts. It will intersect the x-axis. Now getting rid of this, let's try B and see what we got for B. The discriminant, my A is 1, my B is 6, and my C is 10. Discriminant is equal to 6 squared minus 4 times 1 times 10. This becomes 36 minus 40, which is a -4. So in this case, no, because it is negative. It refers to the discriminant. So in this case, my discriminant was negative. That means it will not have an x-intercept. Here it was positive. That means yes, it will have an x-intercept. So the last one that we're going to try here is C. My A is 2, my B is 3, and my C is 5. So let's get some space over here. So my discriminant, clear this up, is going to be 3 squared minus 4 times 2 times 5. 3 squared is 9, take away 4 times 2 is 8, 8 times 5 is 40, 9 take away 40 is 31, so this will not have an x-intercept because the discriminant is negative. So again, recap, when the discriminant is positive, it will have an x-intercept. When the discriminant is negative, it will not have an x-intercept. Alrighty, which of the following quadratic when graph would not cross the x-axis? All I'm asking you for you is when is this discriminant negative? So what you would want to do is check the discriminant just like how we did in A, B, and C to see which discriminant is going to give you a negative. So what I want to do is check each equation to see which discriminant will be negative. And if you do that, you will see that the answer choice is 3. Answer choice number 3 will give you a -64. Alright, so our last lesson for Unit 4. Your next lesson will be on the study guide. No video for that, just work and work and work. Then off to your mastery. Alright, guys, remember, I believe in you, you believe in you, you can do this. Peace out.